As bioprocess engineer trained with a background in chemical engineering, our dream would be that whatever we develop in the lab, what if any industry can take it up?
After working this space of machine learning for almost like now 10 to 15 years, I have built so much confidence in the models that I'm making that I am happy to go against whatever empirical rules are present.
We borrow extensively from sociology, from psychology, from neurosciences. Even with so many theories, we are still not able to figure out the customer.
So research is equals to risk.
No, absolutely. High risk, high reward.
Hi, I'm Amrit, an IIT Madras alumnus and founder of Story 99, where we help the world of tech and deep tech tell better stories. And in this Tech Talk series, I sit down with IIT Madras professors from different departments and labs, where they explain their latest research findings to each other.
So thank you, professors, for joining in this roundtable. And the idea is that when professors from different departments, labs, they share about their specific research and overall the area of work that they're doing, it might trigger some new thoughts in everybody's mind.
Professor Smita is from the biotech department in IIT Madras, and the work that her lab does is directly life-saving. See, there are so many medicinal plants out there, right, that are known to be effective against a bunch of diseases, all the way from cancer to malaria and whatnot. But there are many challenges when it comes to extracting the medicinal elements from these plants, all the way from limited supply of plant themselves to even inconsistent quality. And that's what her lab solves for. So Professor Smita's latest research paper, it documents how her team was able to develop the useful molecules from a particular plant called Banovsha in her lab at much higher quantities than was possible earlier, and of even better quality than you can get if you source it naturally.
What we do in our lab is we are highly interested in phytochemicals. Now, phytochemicals means plant-derived molecules. 80% of the world population is still dependent on herbal solutions, especially for their healthcare. And most of the best highly prescribed medicinal drugs have their leads coming from nature. But many of these plants are endangered, endemic, they are restricted to a particular geography. And when you collect them from the wild for extraction, many a times because of the geographical and climatic variations, the phytochemical profile in these plants will vary, because it is environmental dependent, sometimes even flora fauna dependent, because there is a lot of crosstalk happening, and therefore you see inconsistency in the phytochemical profile, not even in terms of the type of phytochemicals a plant can produce, but also in terms of the quantity of the phytochemicals as per the need. So now if you want to exploit such a plant for the healthcare, let's say, now, how do we ensure that it is available all the time in order to meet the demand? So, wherein we play a role as bioprocess engineers. So, what we try to do is that, as you have heard the term lab grown diamonds, in a simple terms, we can say lab grown plants. When we say lab grown plant biomass or plant, we are also saying that of the same quality what you can find in nature. It is nothing to say that we are replacing, but we are augmenting it. So we identify the plant molecule, we identify the plant which harbors that molecule, and then we produce cell lines and tissue cultures in our lab. They are scalable in closed controlled environment, which we call as bioreactors. Now these reactors are scalable, are optimizable maximally. Otherwise, at any given time, the plant produces plethora of molecules depending on its need. So the content is not maximized, because nature economizes. Nature will produce it only in its required quantities. So as bioprocess engineers, we develop these cell lines, we optimize these cell lines and cell cultures, we bring them in a reactor in liquid state, so that which is easily scalable, and then we scale it up to fulfill the industry demands, whether as a pharma molecule, whether as a cosmeceutical, whether as a wellness molecule. So multiple applications are there. Now talking about this particular paper which you were referring to, there is a medicinal plant called Viola odorata, botanical name. In our Indian traditional medicine, it is called as Banovsha. it has a mention in Unani and other traditional systems of medicine to be used for cough concoctions, for sleep disorders, for nervous disorders, but the mechanism of action is not elucidated. So that is why it is very difficult to standardize such extracts or concoctions. We see a limitation in them becoming a prescribed medicinal drug. So in order to standardize these in terms of their quality and quantity, this technology on which we are working can fill that gap. So we picked up this plant because it is only meant at 5,000 to 6,000 meters sea level. They are only found at that area. They are rare in some of the regions, and they have seed dormancy issue. So cultivation is a problem. They can only be cultivated through runners, not through seed. So the availability of the plant material is a problem. So then we were the first ones years back. Now we have been following these class of molecules which we discovered for the first time in this plant variety, which is called as cyclotides. So once we developed this technology, then we optimized it so that we can have high biomass density. The idea was, how good is this biomass in comparison to the natural plant? So we also did some biological activity analysis, wherein we also explored anti-malarial activity against resistant plasmodium strains. How did it fare? The biomass which we generated in-house, and we also did some cytotoxic analysis, and they were very promising. So that's what this.
Amazing. And we'll get back to asking more questions in it, but I'll pick up peptides. And you said becoming independent, and that points me to Professor Rohit's research.
Professor Rohit is from the Metallurgical and Materials Engineering department, and his latest research is pretty cool. He used AI to discover a bunch of new peptides that can form beta sheets. These beta sheet forming peptides, they have some amazing use cases, from lithium-ion battery components to quantum computing to even AI hardware. But the reason Professor Rohit's research really matters is because there are so many, like billion to the power billions, and much more than that, unexplored materials out there. Peptides being just one example that could never be discovered earlier, even with physical simulation models. But with AI and machine learning, that is finally becoming possible.
Design space of peptides is extremely large, right? It's really huge. We are talking not about like millions or billions of cases. It is of the order of 10 the power, I don't know, maybe of the order of 10 the power 100 or so. So the space is so large that we as humankind, we don't have the resources to go and make each one of them and then start talking about which one of them is better for what type of applications. What we wanted to explore in this particular work was, is there some type of bias is present in the type of peptides that we are exploring? And if a bias is present, then how can we come up with something called as unconventional or non-intuitive peptides? So for this, what we did was we took up the challenge of can we find beta sheet forming peptides? So peptides can have different structures, secondary structures, tertiary structures, and so on. So we just focused on, let's try to find from this huge space which are those peptide sequences which can form beta sheets. Usually the way the thing people would do is, we have some empirical guidelines are there. So for instance, whenever I talk about beta sheet, valine containing peptides are something that come up top. There is something called as hydrophobicity tables, beta sheet propensity tables. So these are some empirical guidelines people have developed, and using that they will actually say that, okay, because these guidelines are there, let's try and make these sequences. The other way we can do is, without following these guidelines, you can use computational approaches. Basically means use some physics based simulation methods. These methods are relatively faster. Computations you can do faster as compared to experimental synthesis. But there are again limitations in terms of time required to do these computations. You can do these computations for maybe thousands of cases, but not for millions, or definitely not of the order of 10 to the power 100, right? So the next best thing is actually machine learning that can be used, that will digest this experimental data, and then it will give us a prediction of what are those new sequences which can result in beta sheet formation. Usually whenever you have multiple sources of models, say I have a computational model and a machine learning model, I will try to select those sequences wherein the two models agree. Usually I'll say, okay, if my physics is also saying this thing is good, my empirical model is also saying this sequence is good, then we would prefer those sequence because two different models are telling me that. But in this work, we creatively or crazily, whatever you want to call it, we specifically looked at those areas where then the models differ. And because my physics-based model is giving me something different than my machine learning model, or my empirical model is saying something different from the machine learning model, that is where we figured out some non-intuitive, unconventional sequences, wherein the machine learning model actually won. It predicted sequences which indeed resulted in beta sheet formation, and they are very counterintuitive because they don't follow any empirical guideline. In a larger picture, it is a way of showing that machine learning models can take you to places wherein new science is available, wherein some new materials are available, which we may not be able to reach if we are just following the traditional pipeline of the current physical models that we have or the empirical models we have.
Usage of AI now allows us to bypass a certain human behavior and tendency that happens even when we approach research, because there is a pattern that we have seen, so our first inclination is to stick to that pattern. And talking about human behavior, you focus specifically on that.
Professor Richa from the Department of Management Studies in IIT Madras, her latest research paper shares how there are much smarter ways to motivate buyers, especially online shoppers, to complete their checkout once they have added items to their cart. And mind you, around 70 to 80% of online shoppers, they add items to their cart but don't check out. Maybe you have been there.
My interest has been in consumer behavior, understanding how human beings behave in the consumption space. How do we make our decision whether to buy this product, or there is an intersection of numerous data points constantly going on in our brains. You might say, oh, I just took that decision casually. No, it's not casually. There are lots of factors at play, and they come together at some time in a certain context, which makes you take a decision specific to that context. In another context, very similar thing, you will not take that decision. In the particular research that you were talking about, the context is about online purchases and putting things in an online cart, shopping cart. It's about how do people take a decision about which particular promotional, offer to positively respond to when there are competing messages. We looked at a simple reminder that, there is an item lying in the cart which you need to go back and purchase. The second was, what if we gave them some kind of a monetary incentive? Will people, come back to the cart much sooner? Then the third was, what if we made them a little curious? We did not give any monetary incentive because, monetary incentive and reminders are very much in vogue, means everybody is using them. We said, what if we don't give monetary incentive, and we give them something which excites some degree of exploration, means we create a curiosity queue and put it out there. Will they respond to this better than the discount or the reminder? Then we said, okay, this is one, but curiosity appeals to your intelligence, it's a cognitive side. What if we appeal to, the non-cognitive, that is the emotional side? So you get some enjoyment, and then we created a queue wherein you get some sense of entertainment or play. When we compared these four in a 4x1, experiment which we conducted online, our findings were that people preferred the enjoyment queue over everything else. Okay, and that comes, very, intuitively you'll say, yeah. But when you look at the body of knowledge that exists in this space, you find that it's mostly about the rational human being. And as I always say in my classes, we come from economics background. A lot of the social sciences, especially marketing, we draw from economics. And the economics is based on the subject of economics is based on the fundamental assumption that human beings are rational, which is actually not true. We are non-rational most of the time. Okay, and you'll see in your decision, you'll see that there is a price discount, every feature is matching, but then there is a small thing over here which interests you, you'll pay a little higher price here or even a higher price substantially. And another thing with human beings is you learn about them, you use something as a cue today, they respond to it like this in a certain manner today. Tomorrow they get used to it, they stop behaving like that.
Dynamically.
So it's a constant dynamic changing behavior, and also the behavior changes because we are in a constantly evolving environment. And that dynamism of the environment constantly interacts with the human being, because human beings are interactive by nature. They go into the environment, they digest that information, and then there's something we call as the customer's black box, and some processes happen there and there is an outcome. So our work in consumer research is constantly about what's going on in that black box, what's going on, and how can we predict what the customer would do. As I said, there are these four experiments we are conducting, but what we are essentially testing is, if I give a certainty with the utilitarian award versus I give uncertainty with this, which one would work? Now, just to give you a little bit of a background, people who have won Nobel Prize for their work, they have found a very strong theory which talks about certainty bias. Okay, so there's this famous work by Kahneman and Tversky, who say that people prefer things which are certain, which makes sense. Again, intuitively you'll say yes. Why would somebody go for something which is uncertain? But there is this motivating uncertainty effect, which says that when things are uncertain, they may also motivate people. But there is a catch to that. So coming to our situation where there is a reward, you will get some discount becomes the reward. So they say, if you are in a situation which is uncertain and you are focusing as a consumer on the reward, so if the focus is on the reward, then people will not like uncertainty, because they prefer to get a certainty when they are considering a reward. Now, things could change if you attach a little process to it. Okay. So the reward is uncertain, but I am creating a task here which leads you to that reward. This task that I am creating, the process which will take you to the reward, if I can make it engaging enough so that you draw some kind of a emotional, happiness or entertainment, then this richness of the process which leads you to the reward will actually make you prefer this reward. Human beings, when they buy something as consumers, they are seeking 6 different types of benefits. Okay, so it could be about saving money, it could be about the quality, and then there is something about convenience. And besides these, there are some, value reflections. So what is my core value? And what is it that I stand for as a human being? Means we all have that, somebody gives you something, this is not for me. There is a certain understanding of who I am. The product that I'm looking at, the service that I'm considering, is it reflecting me? We also have 2 additional, benefits, and these are your exploration benefit. And still another one is your entertainment benefit. The first 3, savings, convenience, quality, they're very utilitarian, very logical. I have got a very clear benefit and this is what I'm drawing out of it. If you look at the other 3, they are more experiential, they are more emotional, there is more of a hedonism there. So the finding is of great use to, of course, marketers, because there is an over engagement with discounts. We see that everywhere. But if you could bring in some elements of entertainment, exploration, so you don't have to give that kind of discount. People are not necessarily looking for discount, which is your common assumption that customer is always looking out for some saving. And that's true about customers, but not always. By the way, 15% may be too low a discount. So why don't we test it at 30%? We said then we won't stop at 30. We brought in 2 more. So 30%, 45% and 60% discount. And you won't believe gamification came at top in all.
So one question I have is in the gamification part, when the message came that you can play this game to know how much discount are you getting, this is how it was phrased.
Yeah.
During that time, were the consumers aware what is the range of the discount they'll get?
No, nothing was told.
Professor Rohit thinking, why are these guys playing the game?
No, especially when you said that the amount of the discount you significantly increased it, even then.
So we never told, even in these other additional 3 conditions where we increased the discount from 15 to, even when we were testing with 15%, for the gamification and curiosity cues, we never disclosed the discount.
Okay. Because I am from a different field, I am thinking it from a completely different factor, which is the factor that in my mind is playing a role is the time or the engagement time that the consumer has to give to do whatever. I mean, how much time you were able to borrow from the consumer. So in the reminder one, no time, when someone plays a game, they have actually invested their time in it. And so that engagement of time
You will
with
be
the
a very good
product,
partner to work for, very good co-researcher for our work, because these are exactly the questions that we look at.
Yeah.
Because, and in fact, there is a theory. This is called as investment.
Yeah.
From the the investment bias. So if you have already invested your effort
Yes.
or time into something, you're likely to prefer that.
Correct. One more thing I would actually consider here is the level of difficulty of the gamification. Because I think if the level is very high, then again the gamification thing can come down.
So when designing this, there was a lot of effort put on designing of it. And we felt that something which is, has some degree of nostalgia, some degree of, ease. Because another thing with customers is they want to win as human beings. You don't want to start on a puzzle and not complete it.
Yes.
So it has to be a challenge, but an accomplishable challenge.
Correct.
Even on Amazon, when I'm doing it, I see those wheels. There are certain games and all which they give. But is it coming to a point where everything can become personalized?
So it's already very personalized. It's already micro, nano, and individual marketing now. If you see your Insta and my Insta, might be you'll see very different kind of content. If I go online, some ads will come to me which are not necessarily coming to you. So it's already, because technology enables us to do that.
Actually, I'm not sure I should mention here or not. My wife is a digital data scientist in a digital marketing company.
Love to meet her actually.
So she is doing exactly that. Her team is identity resolution, which is identifying the customer, and then the later part of the company is just once you have identified this is the customer, then you can pitch them personal ads and everything.
So which means an integration of what this particular research is with the personal identification
That's
of
exactly
that
what
customer,
marketers
and
are
then
doing
integrate
right
it.
now. Why do you think there is so much of marketing analytics and demand for people with analytic backgrounds and statisticians and all?
So in that connection, do you think, because it's now personal space entry, so how do you, the access to such a data, a personal data, does that become a bottleneck for the industry?
I tell you,
marketing?
human beings are so contradicting, means they constantly contradict themselves. So there is another theory, the privacy paradox. At one point they say, my privacy is being, invaded and breached and it's not correct and all. But you give them a little benefit and you ask for them for data, they'll immediately give you data. If the benefit of what you're getting exceeds the cost of sharing your data, people will share data.
When we talk about the applications of these, what is the term you use?
Cyclotides.
And then
Peptides.
The plants, medicinal plants.
Petrochemical.
Phytochemicals.
Yes. So when
Phyto means plants.
Okay. So phytochemicals, from an application point of view, do we have to separate out a molecule first and then think about its application, or we need that collection and the composition?
So very, very logical question. And if you go to the traditional medicine side, it's more of an holistic approach. So what the traditional medicine believes is that there is a synergistic effect of the concoction of molecules present in this herbal biomass, which is bringing in the impact.
Correct.
So which means that key principle for a particular mechanism of action might be brought in by the single molecule, but there can be a complementary effect which is brought about by another molecule.
Yes.
Now if you talk about wellness, let's say a particular extract is antioxidant in nature, is also good for your liver, and is also antimicrobial in nature. So this is a synergistic effect which is coming in for a holistic wellness. And if you go to pharma, in biopharmaceuticals, mostly they go by single APIs.
Correct.
So which is active pharmaceutical ingredient, and rest is all formulation and rest of the impact. And now there are merits and demerits associated with both the strategies. A single API may be very useful in a particular range, but sometimes it may be very, very toxic to the other organs, liver toxicity or kidney toxicity. So one of the limitations of these concoctions is that there is no control over the ratio of these phytomolecules which are present, because you are only selling it as a concoction, and these are not prescribed. If you are dependent on a concoction which is on a herbal extract which has been procured from nature, then anyways it comes with an inherent limitation of non-uniformity, depending on from which location it was collected, depending from in which season it was collected, and that is why you see a variation in the biological activity as well.
So like with this context, now that the processing, the
bioprocess,
the bioprocessing lab
Correct.
that you have developed, that will actually allow us to overcome that non-uniformity as well, right?
Absolutely.
Like beyond optimization, it is actually about figuring out what
Standardizing.
is the, yeah. So can you go to the extent of saying that not only we'll be able to reach the levels of the extracts available in the nature, perhaps we'll be able to even surpass.
Absolutely. I'll give you an example. We were working on Alpha Tocopherol, which is a vitamin E component, most bioactive component of vitamin E. Now, this Alpha Tocopherol we wanted to extract from sunflower. Now, it is known to have large amounts of alpha tocopherol. So, we picked up a commercial hybrid seed variety from TNAU, Tamil Nadu Agricultural University, and we wanted to use that to develop in vitro cell lines, which I was talking about, and take it as a bioprocess. So, we engineered the cell line and we could do a 10-fold enhancement. So, through that cellular engineering. You said that you had machine learning tools to find out some novel beta sheets peptides.
Yes.
But don't you think that even if we are able to see novel things, but experimental validation is really needed before it can come to any application side?
Yeah. So I didn't mention this part. So when I said we found out novel and non-intuitive, these are all experimentally validated. The way the entire work progressed was, machine learning job was to predict that which will be the sequences which will result in beta sheet formation. So say the model suggested few candidates. Those candidates were then actually synthesized in the lab. So we collaborated with Argonne National Lab. Dr. Chris is there. So he actually made the peptides. We did FTIR. Using FTIR, we figured out whether beta sheet formation happened or not. So all the results are all experimentally validated. We had a control group also. So we randomly took some 50 peptide sequences to know what is the overall probability of, if I randomly select from this design space, how many beta sheet formation peptides can happen. So to just give you some numbers, randomly selection will have a probability of the order of 1 to 2%. Very low possibility of finding a beta sheet forming peptide. And these models' accuracy was somewhere in the 60 to 70% range.
Now, generally in computational techniques, when I collaborate with computational biologists, what I've seen, as you said in your talk as well, that they use more than one techniques, so to say more than one models, and then whatever is the intersection, we feel you are more confident to take that pool for experimental validation. Now, but you said something very different. So then there's a lot of risk involved in such strategies. One thing. The second thing is,
so research is equals to risk.
No, absolutely. High risk, high reward. No, but the second thing is that when you say machine based and when you say empirical, the empirical is also based on some knowledge of the parameters which have been included empirical.
Yes.
So how do you differentiate?
Yeah. So what we have to understand is, how did these empirical rules came in the first place? These empirical rules came into the first places based on whatever peptides we have made so far. And the whole point of this work is to show that the space of the peptides that we have explored is so minimal, whatever rules we have derived from that may not be fully correct. And what happens when the machine learning models go against the rules that we have, the empirical rules we have, we specifically explored that space. Usually a computational theoretical person would also do what you said. They will say that when my model is matching to the empirical rules, let's go there.
No, there's more confidence.
Because there is more confidence. However, after working this space of machine learning for almost like now 10 to 15 years, I have built so much confidence in the models that I'm making that I'm happy to go against whatever empirical rules are present here, because I also know that the empirical rules also are not correct.
Don't you think it will be useful for anybody to now know as a step forward that what is that missing thing?
Yeah, so
That will be important.
yeah, so now this becomes a little case to case. Like these models are specific to beta sheet formation and so on. So general advice would be that moving on, whenever your models and the current traditional modeling scheme or the empirical scheme do not match, do not inherently assume that the machine learning model is incorrect. Give a chance to the model also and look for whether there are something missing in the empirical approaches also or not. It does not mean always ML model will be correct. In our work also, it is not that whatever places where the model and the empirical rules did not match, the model was always correct. There were both the cases. In fact, we created a classification.
How do you differentiate then?
So differentiation comes from the experimental output. If the experimental output says yes, beta sheet formation has happened, the model is winning. If the
validation happened, which means that it was possible.
Yeah.
In fact, this paper is called non-obvious. The paper stated that he believed, or the team believed, that there is a bias happening here. So that is your hypothesis. If the paper would have eventually said, you know what, actually there is no bias, that's the right approach, it would have come out. But I think he has shown that in his domain.
And then experimentally one could synthesize it, which means it was indeed possible. Correct me if my understanding is wrong. That AI ML, it's kind of a black box modeling.
So, I mean, yeah, to a certain extent, yes, it is black box, but there is a lot of research happening on interpretability of these models. Obviously, the research is not to that level that we'll all be satisfied that we understand what is happening in the model. There is a nature of black box still left in there. So, just to give you some more idea, this machine learning model that we built take input as things like what is the hydrophobicity of the amino acids, some of the things that we know should make an impact. And during the process of the modeling, if the same things that we believe should be of higher importance are also indeed given high importance by the model, then we have more confidence that the model is learning decent things. But at the same time, what will happen is there will be few features, there will be few inputs to the model, which the model will say that yes, it is important, and we would not be sure.
This sounds now interesting to me. So see, your initial thing is premises that existing knowledge is very limited, and therefore you're bringing an AI ML to actually explore and widen that space of knowledge which already exists. Now, if when you say that I believe that this is the kind of, what was that word,
Hydrophobicity.
Hydrophobicity. Okay, that knowledge, it comes from your conventional existing knowledge.
Yes.
So aren't you kind of priming or developing this structure with the assumptions of the existing knowledge?
Yes. So the way we do it is, along with this existing knowledge, we also give some other things which we are not sure whether they'll be useful or not. So we almost like give a lot more knowledge than what generally is considered, and we let the model filter out whatever is good or not. The input to the model is roughly around 90 or so variables.
Okay.
And from that 90, the model itself down selects how many of those variables are important. So roughly around 20 or 30 variables are left in the end.
I have another question, just exactly here. So when you say the model filtered out from 90 and came down to 20, do you see these 20 are in line with the conventional knowledge?
Yeah. So this is
that's
where
again a bias, isn't it?
So this is where we find three categories. One is that it matches
The conventional.
the conventional knowledge. The second thing is it will not match the conventional knowledge. I mean, these are two broader. Where it matches, well and good. There is no harm because it is matching with whatever the known scientific literature is. When it does not match, again you can divide it into two. It is not matching because the model is incorrect.
Okay. Okay.
The second possibility is it is not matching because there is a new knowledge there which we never thought about.
I'm talking about that second part.
Yeah.
Anyways, these ML models, AI ML models, the user will have to train the model using the data which is already available. Now, you said that there is already a limitation. So, please correct my understanding. So, what I am understanding here is that the variables are limited based on the data. So, those variables and the data is put in. The AI ML model will try to find the possible correlations between these and then try to give us some novel solutions. So, maybe rather than variables being limited in knowledge, because that is what was user defined, but the correlations were limited, which you said were physics defined. And some of them might have been missed that this model is now giving us.
The inputs to the model, we did use some of the variables which are generally used, but also at variables which are not so commonly used. Yeah. What we found out was a combination of both these new variables introduced as well as the conventional variables, coupled with this layer of highly non-linear model is what giving us a better predictive model.
So, very interesting work, Richa, and thank you for inviting, because then you get to know what other colleagues are doing. Sometimes because of the different departments you don't get to meet. So, Richa, in this particular study, what I felt was that, do you think, your opinion on that because it is also segmentation of the customers depending on their own personal needs, their environment, their own limitations or their own context, they may prefer to have different choices. So, as you said, you had done repetitive studies and you took care of that. So, how did you manage to take care of personalized, because sometimes it is person dependent as well.
Like, just to add to that, I am like father of 2 small kids right now. I don't have time to play any sort of games to figure out how much discount is coming.
Correct.
So at best what we can do is we can try and control for the variations amongst our participants in the experiment. And that's where you see we are doing n number of customers we are taking.
So the cohort size was around?
Cohort size was overall, we took around 1500 customers. Okay. But
and these are blinded customers or?
These are all blinded customers. Because we can't take those details. There is some degree of demographic data that we collect: age, income, gender, and some
because that might
measures
be needed for you to randomize it.
Yes, that we do. Okay. And we try to ensure that there is a good representation and a good mix there. Human beings are so difficult to predict. So you have to constantly see, was it because I asked them to place a certain item in the cart and there the saving made sense, okay? Versus, as he was saying, that I don't have time. If I create a time constraint, would people behave differently? If I change the product, let us say instead of talking about sneakers, which was the subject over here or the product over here, I say you are purchasing an air conditioner. Wouldn't a discount matter much? I am confident a person is not going to prefer a game or something like that, right? So that would be another finding. This is just a piece of the puzzle. Correct. If you look at social sciences, if you look at consumer behavior and marketing space, the number of theories that are there, and we borrow extensively from sociology, from psychology, from neurosciences, every domain, every discipline you can think of, even bio, we take all those. Even with so many theories, we are still not able to figure out the customer. We have big data. What are we doing? All the analysis of the data that we do for the consumer is just to figure out and predict the next purchase of the customer. What should I give as a discount? What kind of placement should I do so that the customer prefers and picks up my product? So it's very difficult. So in my classes, I'll normally say that, we are going to discuss this theory, and it will tell you the customer behaves like that. But not always. There's always this, even if in economics we talk about the law of demand. Prices go up, people will reduce the quantity price, but that is also under certain conditions, under certain assumptions. So these theories, you will have to look at the context. If you look at the planet, It has got different climatic areas, and because of difference in climate, we have different vegetations, different flora, fauna, and all that. And the human beings living in those different climatic regions, their composition also varies. Not only, which is physically obvious, but internally also it is different, right? And I believe very strongly that nature in a certain region provides for the people in that region. Okay, so you are suited to the ecosystem that you are living in or you come from, right? Now, there is a variation in nature. Now, this variation in nature could be something which is good for us, right? Now, when we take that individual, element, molecule out and we create it, we produce it, and we, amplify it in a lab, have I kind of tried to create a uniformity which may not be what people need? How could, biotech take guidance from nature itself and ensure that what they are creating is not uniform, but it can be matched to the composition of the person?
Absolutely, very true, and that's where personalized medicine is now coming in. So, and that is where our traditional medicine, the Ayush system, used to bank on. According to our traditional medicine, or you say Chinese traditional medicine, the focus is more on the holistic wellness, wherein it is not only the molecule. Like for example, if you see the APIs, let me give you an example, one of the molecule which we are following, camptothecin. Now it is the lead molecule which is extracted from plants. We are in fact importing camptothecin from China and others, so there is a dependency. Now cancer is rising. Now it's not that this is going to be the solution, but sometimes to fill that gap. Now the need of the hour is to find solution for cancer. Now in such cases, when the camptothecin demand is increasing, the plant available, both the plants from which it is extracted are critically endangered now. One native of India, another of China. And European Union has declared camptothecin as one of their essential medicine. Because they don't have the plant. So they are looking for technologies which are indigenous to produce this. Now in such cases, any such technology which can give this single molecule even can be beneficial to augment what is already existing. Now coming to the holistic part of it, that is where this kind of a technology can also play a role, because it is not only giving you, if you want, it is the wish of the customer. If you want, you can do downstream processing of the biomass and purify those single molecules and use them as APIs, whether as combinations, whether as a single molecule drug, depending on what is already existing, or something new which you would like to build. Or you can choose to create a high quality enriched biomass which has lot of these molecules, wherein I am sure AI also plays a role. And obviously marketing would also have to play a role, because then the consumer has to be made to understand that the plant biomass, which is, although it is lab derived, is also of a similar quality as you were dependent from nature on. So I think the AI plays a huge role, wherein you can decipher that what are these molecules playing a role in, whether it is synergistic, whether it is antagonistic, which will also give a cue to the pharma companies that maybe it is good to have 2-3 molecules together and become somewhere in between that single API versus the holistic extract based drugs, and become something which is more optimized, neither a single nor completely uncontrolled.
Huge business opportunity there, isn't it? This could be something lab to market exactly, and we could have a
lengthier discussion.
Yeah.
So one last thing is, we are in GDC, and what happens here is taking a professor and students team who is doing deep tech or some tech and saying, are you inclined to take your fundamental research to a translational direction? Maybe it becomes a startup, whatever, things like that. And that is what is taught here. That entrepreneurship then becomes very different than research.
Gopalakrishnan Deshpande Center, GDC, is an entrepreneurial capacity building organization for Indian deep tech researchers like IIT professor and their students, helping them pick up both the skills and the mindset to become an entrepreneur. And it offers various programs all throughout the year, open to all technical institutions, not just IITs, across India.
Professor Smita, I think, has been part of some cohort. A little bit about what happens in GDC and what your experience was.
One of the very good programs which I have seen the incubatees getting benefited out was their customer discovery program. I incubate. So in that program, it used to be an 8 weeks long program, very extensive, but it made my eyes open like anything. I could really enjoy that program in the sense that we are researchers, we are more into lab based discoveries. Now everybody as a researcher wants a tech transfer. Our dream would be that whatever we develop in the lab, what if any industry can take it up. So what I realized in this was that our focus as researchers is always on the technical feasibility to prove our hypothesis, whether it is right, wrong, to get deeper into research. And one of the limitations of that aspect when you become a bio entrepreneur is that we don't realize the fact that when you enter into entrepreneurship, it is about business. Now, how do you make a transition from a conventional researcher into an entrepreneur is what it trained us into. That both the aspects are equally important and should go hand in hand. The business model canvas, the revenue model, the finance should also start from the very day when you are looking even into ideation stage. So that is what the learning was from that program. It helped us to identify that what we are trying to solve, whose problem it is, whose pain point it is. We also wanted to validate our hypothesis that is this really a pain point? We are thinking that demand supply gap will be reduced. We are assuming that this would be benefit. So this gave us an opportunity to validate our assumptions. So that is how the GDC program was very useful. And it also made me, I must mention, during the discovery, customer discovery interviews, validation of our hypothesis, we came across couple of industries with whom now I am collaborating with.
Very good.
That is very good. Yeah.
Really nice. In fact, what you are telling is, in design thinking, we have got three lenses we talk about. So the first one, which normally the faculties from tech institutes normally look at, is the feasibility. Okay, so feasibility is the technology readiness.
Correct.
Can I solve this? Can I do this with the existing technology or whatever I am kind of creating in the lab? Can it be giving me that technological advantage? The second part is your customer discovery, which you talk about, is the desirability. Whether what you are, creating, does the customer really want that? Or does it customer need it? Or does the customer will the customer like it? Because ultimate test in the market is the customer. You may create anything. The customer does not like it, it won't sell. And that's where my work mostly is, on the customer side. And the third lens is that of viability, which you said, So I can create a technology which solves a problem, but it is so expensive. I can't do anything about it. And this is a problem which I often see with our tech side of the students. That the product is good, the effort they have put in to develop the technology is humongous.
There is a bias,
There-
because it's your baby. So
Yeah.
you become biased about it.
Exactly. What you're saying is so right. It's my technology. I put my heart and soul and so much
Why
effort
nobody is
into it.
taking
That
it
bias
out?
of that investment, effort invested. So you don't want to let go. But a good entrepreneur is one who starts from the market need. What am I doing? Can you vet it with the customer? Do they need it? I remember there was
product
this
market fit.
product market fit and customer's pain point.
Absolutely.
If you cannot solve a problem for the customer, why should the customer pay? The customer is in those cases very clear what they want. Some kind of a emotional reward, some kind of a rational sense, making decision, very clear. Without that, your tech products won't take off.
So I like to think on this in terms of TRL levels. So technology readiness levels. I think my personal belief may be against what the setup is about.
Non-obvious belief.
Is that not everyone has to work in the complete range of we have to choose our segment and then accordingly we have to go there.
Very correct.
Someone from science background, someone from doing physics deep into quantum mechanics and so on, they may be working at TRL level 1. I'm not sure if they should also look into whether they can find a customer who has some pain points wherein they can come in. Yes, they should have a broader vision that how their science effort can actually later result in research in TRL level 2, 3, whatever. And then other spectrum of people have to come in and then they have to do their own work and then take it from TRL level 3, 4 to 7, 8 and so on. Yes, I am very much interested into going into the TRL level 4 to 8 zone. Mostly my research has been focused into that 1 to 3 range. How I can go to that is still something that I'm figuring out. And although I was not familiar with these terms that are being used, which is the customer pain points and the product custom market fit, but I always had that feeling that whatever I'm developing, I'm not sure how unique it is and how it will sustain the market and whether it will be a fit to the market. Still looking for those ideas wherein I'll be able to do that. This is something, in fact, I very much want to do, but still not being able to do that.
Amazing. Maybe there is some GDC program which might benefit you at some point of time. Thank you so much, professors. It was a great, deep conversation. Hope you also enjoyed talking to each other as much as I did listening to everybody.
Again, thank you so much for inviting us. Lovely chatting with all of you.